In this video, we're going to look at these problems on page 8 of the 7-1 slides. Our first example, an experiment consists of tossing a coin 3 times and observing the resulting sequence of heads and tails. Describe the sample space S of the experiment, determine the event E that exactly 2 heads appear, and determine the event F that at least 1 head appears. Okay, so the sample space S is going to be the set of H, H, HT, TH, TT. There are 4 elements in this sample space, and there they are. Next. Oh, I'm sorry, are we flipping this 3 times? We are flipping this 3 times, not twice. My bad, sorry. Helps if I actually go back and look at the problem as I'm typing it. Yeah, we're flipping a coin 3 times. Okay, well, we can do this as a tree diagram. That's maybe the easiest way. Each time, you can get a head or a tail. So that gives us head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. We've got it, and that is our sample space, those 8 items. We can put kind of a set of braces around that with commas everywhere. So next we're looking for the event E, where there are exactly 2 heads. Okay, so we look through our list and look for the places where there are exactly 2 heads. That's HHT, or HTH, or THH. So this event is made up of HHT, HTH, and THH. Finally, for C, we're looking for the event F, where there is at least 1 head. And that's everything except for 3 tails. So that's going to give us HHH, HHT, HTH, HTT, THH, THT, and TTH. All right. Moving on, we've got one more question on this page. So now we're looking at an experiment that consists of rolling a pair of dice and observing the number that falls uppermost on each die. We want to describe an appropriate sample space S for this experiment and determine the events E2, E3, E4, E5, and up through E12, such that the sum of the numbers falling uppermost is 2, 3, 4 through 12, respectively. Now, it's not too hard to describe that sample space. The sample space is going to be every possible pairing of dice, and order matters. So not only that, but we can double up. We can have 1, 1, we can have 1, 2, we can have 2, 1. A nice way to do this is sometimes to do a product table, and we can just list the possible rolls on either side. And so we get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. And it's pretty obvious how this is going. We're just going to get each possible combination of two numbers in either order. Now, the only thing I want to mention here is that this really isn't the sample space. This is a collection of the possible values that we could roll. If we want to write the sample space, we would write it as S equals the set of the ordered pairs 1, 1, 1, 2, and so on, up to 6, 5, 6, 6. And we're not going to write it out like that because there's no point in duplicating our efforts. And this table helps us in another way because it makes it really easy to answer the second question, which was to find the events. What were we saying the events were? They're E1, E2, E2, E3, E4, etc. And the reason that this is so easy is that if we look here, that's all the possible values that will give us 2 when we add them together. So the set of E2, or the event E2, is just the set that includes both rolls being 1. We look along this diagonal, and we get 2, 1, and 1, 2. So E3 is the set of 1, 2, and 2, 1. If we add those together, we get 3. And we can look along any diagonal to find the set that we're looking for. So for E4, we get 1, 3, 2, 2, 3, 1. E5, the set, 1, 4, 2, 3, 3, 2, 4, 1. And these seem to keep getting bigger, but we're going to reach a point before long where they start getting smaller again. So E6 is going to have 5 elements. That'll be the set that has 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. E7 has 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. But notice now that we've used every possible combination that has a 1 in it. So when we go to E8, we have to decrease that size because we can't have 1s anymore. Our first element is going to be 2, 6. And then we will have 3, 5, 4, 4, 5, 3, 6, 2. And now we've used all the possible things that can have a 2 in them. E9 is going to be the set with 3, 6, 4 5 5 4 6 3. We've used up our threes now. E10 is going to be the set with 6 4 or 4 6 rather, 5 5 and 6 4. E10 11 will be the set with 5 6 and 6 5. And the only possibility for E12 is the set that contains 6 6. All right, that is it for this video. If you have any further questions, please get in touch.